So today we're going to be taking a look at section 3.1, which is going to have us using a problem-solving strategy. So our overall goal with this is to take a story problem, a bunch of text and words and all that fun stuff, and turn that into a mechanical problem. So the way I like to think of this is these two separate types of problems. A story problem is you got all the text and everything. A mechanical problem would be something akin to what we have been working with up here. It's just, here's a problem, solve it. Here's a problem, solve it. So we want to turn all of that English into algebra. Now, the unfortunate part with this section, with I think 3.3 is going to have this as well, and just about every single story problem that we are working with, there is no universal this always works method or strategy for all of these story problems. I think there are a couple of universal factors that generally make it a bit easier to go through and solve these things, but there is unfortunately no here's how you always solve them strategy. I wish I could give that to you guys. It just doesn't exist. I am, however, going to be giving you guys, and I'll show you guys this here shortly. There's an English to algebra document, and actually a couple of them that I have posted to Canvas for you guys to go through and take a look at that should help with translating these things. I'm going to show you guys just one of them here. So this is the English to algebra page. So what this has is here's the column of our words and our expressions, our English statements as they were, and what they translate into in written as an algebraic expression. So if we see something written as m more than n, we can change m and n to be whatever numbers. What does this translate into an algebraic statement? And it translates into something like this. If we're working with something where we have y take away z, what does that look like as an equation? Well, it translates over we have right here. So we have this English to algebra document. It's got a whole bunch for addition, subtraction, multiplication, division. It's got a lot more for division. It also has some for when we are working with and writing in an equal sign here. And this is probably one of the more important ones that we're going to need and going to want to work with. So we have a bunch of buzzwords that are going to be showing up in here. Let me figure out how do we translate those over again into algebraic statements. There are some extra ones for geometry problems. There's a couple others for other word problems that we are going to be getting to later on. But again, very, very useful document that we have here. And this is, if you go to our Canvas site, I'll show you guys this here in a second. It's translating English into algebra. And you guys are more than welcome to download this document, save it, print it out. I've had students in the past print it out for themselves, and they continue to write in additional things with addition, subtraction, and whatnot as they find new buzzwords that are going through the homework. I think that's a great idea. You are more than welcome to do that. It's your choice on what you want to do with this, but I highly recommend if you are someone who is struggling with this material as we're going through the homework, or you want some pointers with story problems and as a generality, this is a very, very useful document for you to have. So I'll take a quick moment here. I'll just show you guys where you can find this on our Canvas site. Taking a bit of a side tangent here, but I think this is worth showing all the same. So from the front page of our Canvas site, again, this is seen it through my view, but the main way is going to be the exact same to get to it. So the main site, going over to Files, go under the Useful Math Files section, folder. And then if you notice, I've got 3 of these here, English to Algebra 1, the Word document version, and a PDF version. I was looking at the first one here, so I'll click on the PDF. And it's the same thing that we were just looking at. Now I do have an alternate version of English to Algebra document on here. You are more than welcome to use this one as well. The only reason I didn't reference this one is because this one is 6 pages long versus the other one just being 2. But there is nothing wrong with you going and downloading and viewing this one as well. What's nice about this one is it does have some other examples that go along with it. I think it even has, a little more in-depth information. It's got a couple exercises and problems for going through this as well. So if you want additional practice with these, This is all available for you guys as well. But again, that's going to be under our Files section, Useful Math Files, and then English 2 Algebra 1 or 2. It's your call on whichever one you would like to use. But I do want to let you guys know about those being here because they're going to be very useful for 3.1, 3.3, and pretty much all story problems that we can and will be working with. Or at the very least, it's a good starting point for what we're working with these things. So I'm going to jump us back to our notes now. So as we're going to see when we're going through and writing these things out, if it wasn't apparent with how many different buzzwords and different ways we translate these things, the parts that can't show up with that, do not rush the process for converting or translating a story problem into a mechanical problem. I think this is pretty much, you could equate this to, this is the setup step. This is the part of the problem that there isn't really a, here's the step-by-step mechanical procedure to go through and solve this thing. The mechanical portions are when we have an equation set up for ourselves, and then we're using stuff that we've done earlier in this quarter and stuff that we've done in our previous classes. It's very mechanical. There's a step-by-step procedure, and we just follow that. It's all of the setup for converting and translating that we do not have a direct, here's the step-by-step process for, which again means do not rush your process when you are doing that. A lot of people will read it once, write something down, and just solve it, and then they get the wrong answer. So, well, I don't know why it was wrong. Because as soon as you start trying to figure out how to translate it, something might break down from there. So be very, very methodical in that translation process. It's absolutely critical that you are for these types of problems. Okay. So we're going to go through and set up a couple of these examples here. Yeah, aiming primarily to focus in on how and why we are translating these things, and then we'll go through and solve them accordingly. So we'll go through a couple of these, and then we'll go through this one, we'll translate it, go over to our whiteboard, and go from there, and then solve it there accordingly. So we're told to solve the following problems. The difference of a number and 8 is 4. Find the number. Okay. So when we are going through these, my recommendation to everyone as you are reading through these problems, you are looking for buzzwords. Tell you what operations could we be doing, or what won't we be doing, anything like that. So we're looking for buzzwords in this thing. And again, I think the biggest universal truth with all of these story problems, my recommendation, read through the problem at least like 2 or 3 times. As you're writing things down, go back and read it again. As you're writing something else down, go back and read it again. It really cannot hurt to read these things over and over and over. There's no limit to how many times that you can be reading them or should be reading them, right? That. So again, the difference of a number and 8 is 4. We need to find what that number is. So we need to translate this thing into a statement. This is the one we're going to reference. I'm going to jump us over to our whiteboard so we can start writing things down, and then we'll start solving it from there. But as I'm going to reference this, I'll reread it a few times. I'm working with problem 1 in our story problems here. Okay. So again, our first example, I'm trying to translate that thing into a mechanical problem and solve that out. So again, I'll reread it. I've got another screen over here, but I'll reread it for us. The difference of a number and 8 is 4. And again, we're looking for buzzwords. Now, when you're going through these, one of the main ones that I recommend taking a look at or finding there is the word is. Is translates into an equal sign. So it means I'm going to have something equals something else. The other really nice part about finding that equal sign that is equal to, again, a bunch of buzzwords for that, we can almost think of that as taking our sentence and dividing it into 2 halves. So I have everything before that, more often than not, is the left-hand side of my equation. And then everything that comes after that is going to be the right-hand side of my equation. There are, and I will put the disclaimer on there, there are a couple instances where that will not always be the case. but more often than not, that's a good rule of thumb to follow as we're going through and solving these things. So again, reading the problem out, the difference of a number and 8 is 4. So the really nice part about this, okay, so the difference of, so I've got stuff there is, so that's our dividing part, 4. So I'm going to have something on the left side of my equation is 4. The right-hand side is going to be something equals 4. Don't know what that something is yet. We're going to get to that here shortly. But I know that that should equal 4. So now I'm working with, again, the difference of a number and 8. And now we can just look at that part of the equation, the sentence that we've been given, as it were. And that's all we need to focus our attention on. So the difference of a number and 8. So we have to think to ourselves, okay, buzzwords in there. So I've got difference of, that's going to tell me something about an operation that I'm doing. A number and 8. So a number, it's an unknown. You could use x, you could use n, you could use a, you could use any variable you want. And 8. So we have a number, we have a variable and a number, and we know we're subtracting. Now, here's where we might be asking ourselves, okay, so the difference of number and 8. So I'm going to be subtracting something. Is it going to be, we'll use x for the variable, for the number here. Is it going to be x minus 8 or 8 minus x? And the ordering absolutely does matter when we are going through and writing these things out. And if you're someone who isn't aware of what ordering we should do those in, that's fine. I'm going to jump us over to our translation PDF that we had here, and we'll go find that out for ourselves now. Let's take a look at that. So looking for the difference of something and something else. Okay, so we have, there's some buzzwords in here. Okay, difference. So it's telling us subtraction, so we're good there. And now let's find an example of this thing. So we have subtracted from the difference between x and 7. So a slightly different wording that we have here, but we're going to translate it all the same here. So the difference of x and 7, the difference between x and 7, this translates into the first thing minus the second thing. So our problem told us the difference of a number and 8. So going back to our whiteboard, the difference of a number and 8, we have x minus 8. Just a little extra thing that's shown up there. So now, before we get to solving anything, let's reread the problem and see if everything that we have written down is accurate. So we're told the difference of a number and 8 is 4. And then find the number. We have this thing translated out correctly. The algebraic equivalent of what we have been given as an English statement is correct. Now we can go through and just solve this thing like we've done with all of our previous problems. Adding 8 to both sides. Should probably write in an 8. Go. We're getting x is equal to 12. And we have our answer. So again, as we're going through these things, the setup is absolutely critical with these. So we'll go to our second example that we have. So again, I'm reading this off from the other page, and we'll translate this over here. I'll read it a couple of times. We'll go through it. We are told with our second problem, find 3 consecutive odd numbers whose sum is 291. Again, find 3 consecutive odd numbers whose sum is 291. So again, translating this thing over, looking for any buzzwords that are showing up. Again, I like to look for the equal sign. It's going to divide our sentence and our equation in half. And our buzzword in that is going to be the word is. So I have find 3 consecutive odd numbers whose sum is 291. So I have something is or equals 291. Now I'm just looking at the first half of this thing now. find 3 consecutive odd numbers whose sum, we got some buzzwords in there, the sum. I'm going to jump us over to our PDF, but I'm going to give you guys a quick 10 seconds or so. Think to yourselves, what mathematical operation, so addition, subtraction, multiplication, or division, does the buzzword sum correspond with? Is it addition, subtraction, multiplication, or division? So I'll give you a second to think on that for yourself. And if you're someone who's saying, I don't really know, I'm not sure, again, that's fine. That's why you have this document. So we go through, okay, let's take a look at addition. Does the word sum show up anywhere in here? So look at the top, the sum of showing up in here. So the sum is going to correspond with addition. So I'm going to be adding things together for this problem. So I'm going to jump back to the whiteboard here. So again, rereading the thing up, find 3 consecutive odd numbers whose sum is 291. Okay, so I'm going to have 3 numbers being added together. And this I want to show you guys is I'm going through it in some additional gory detail, but I do want to show you guys the general thought process on how you could go through writing these things out and revising them and rewriting them over time. So let's take the general idea of what we're doing here. I have 3 numbers, and I know that I'm going to be adding them together. I don't know what the numbers are, but I'm adding 3 numbers together. So I am going to choose to start by writing out 3 numbers adding together. Don't know what they are, but I'm just going to write them out as some variables for now. So I have my first number plus my second number plus my third number. Again, don't know what they are. I'm going to revise this because I do have other information that will help me out with this, but I have 3 numbers being added together. I'm just starting with that, and I am going to revise it. But I at least have, at the very least, 3 numbers whose sum is 291. So now I need to revise this because I have been told I want to find 3 consecutive odd numbers whose sum is 291. So we got to think on that. Okay, so I want 3 consecutive. Okay, so the numbers are going to come following one another, and I want them to be odd numbers. So to think on that, go off to the side here. I'll put our thoughts down. So let's say, because I don't know if this is the answer, we want 3 consecutive odd numbers. So let's think of what a potential first odd number could be. So I'm going to use the number 5. So if my first number is 5, what would the next consecutive odd number be? Okay, the next consecutive number is 6. But the next consecutive odd number is going to be 7. Okay, so it would be 5, and I would have 7, and then the next consecutive odd number after that would be 9. Okay. So we can count up in that regard. So let's think of, we'll take a different odd number. Let's say we're going to start with the number, we'll go 21. Why not? So that's my first odd number. What would my next consecutive odd number be? Okay, the next consecutive number would be 22, but the next consecutive odd number would be 23. And the next consecutive odd number after that, well, that'd be 25. So now I have 3 consecutive odd numbers. Now let's go to the general sense now. Now let's say I had my first odd number was X. It could be 5, it could be 21, but it's X. How would we calculate what the next consecutive odd number would be? Well, let's look to our previous examples that we had. How did we go from 5 to 7? How did we go from 21 to 23? How did we find that next number? Well, we took the original one that we were given, and we added 2 to that. 7's 5 more than 2. 23 is 2 more than 21. So I would take whatever my first odd number is, which we're assuming to be x here, and it's going to be that number plus 2. Say, okay, well, how could I find then what's the third consecutive odd number? Well, judging from our, use red here, from our middle one that we have here, what did we do to get to that last one? We added an additional 2 to that. From 23, we added an additional 2 to that. So if we were to write this thing out in our general sense here, there's a couple ways you could write this out, but I think the most condensed way of putting it is saying it's the original number, x, plus 4. Because I'm adding 2, get the first part, the next consecutive odd number, and then adding an additional 2 to get to the last consecutive odd number. So I'm taking the original thing plus 4. So I have, here's a number, here's a number, and here's a number. So I have 3 consecutive odd numbers. And again, I don't know what they are right now. We're going to go through and we can find that out later on in the problem. The rest of the problem will give us our individual numbers after we have done this correct setup. So with these thoughts in mind, let's go back to our problem that we were working with. We have 3 numbers adding together to equal 291. We are now in our next line going to revise that to be 3 consecutive odd numbers that are adding together to give us 291. So our first number is x. Our second number is x plus 2. It's our next consecutive odd number. And our last number is going to be x plus 4. So I now have 3 consecutive odd numbers adding together to equal 291. And if you're going through this process on your paper and you say, well, I don't want to keep that original line because I revised it, you can go ahead and cross it out or something if you want to. Nothing wrong with that. Nothing wrong with writing an equation and then going back and revising it as we are going through and thinking on this process. So again, before we go into solving this thing, let's do one last check and read through, make sure that this thing is translated properly. Find 3 consecutive odd numbers. So we have 3 consecutive odd numbers here, whose sum, again, that's telling us that we are adding those 3 numbers together, whose sum is 291. I think we've got everything translated correctly here now. And once we have all of that translated correctly, fantastic. Now I can just focus on solving this thing as if it were any other problems that we've done in the past. So I'm combining like terms on the left-hand side. I'm getting 3x plus 6 equals 291. Oops, there we go. I want to get the 3x all by itself. I'm doing this, this math here off to the side with a calculator. And then I do not want 3x, I just want regular x, so I'm going to divide both sides by 3. Again, off to the side, just using the calculator for that. Oops. And I'm getting that x is equal to 95. Now, if you're looking at this and saying, okay, great, I'm done, I found my x value. Wrong. We were told find 3 consecutive odd numbers. We just found one of those odd numbers. We need to find what those other 2 are. So thankfully, we have a process to do that. If our first number is 95, what is the next consecutive odd number going to be after that? Well, it's going to be 95. Add 2 to it, we're going to get 97. Add 2 to that, we're going to get 99. Alternatively, if you wanted to, you could plug this thing into the original equation. And then solve it out this way. We find that we get 95 plus 97 plus 99. We could add those numbers together. Plus 99. Doing that off the side, off screen. And we're good to go. That works there. We have our 3 consecutive numbers for our answer. So multiple ways you could find them at that point in time. But again, make sure you are answering the question that has been given to us. We're told to find 3 consecutive odd numbers, which means my answer needs to have 3 consecutive odd numbers. If you just leave your answer at x equals something, we're not done. Going to lose points on that. You need to answer everything that we've been given. Okay. So I'm just going to move us up here. And we'll take a look at the third problem that we have. So jump us over to the notes. I think this one's a little bit more complex. I'm going to give you guys a chance to take a look at it as well. Okay, so we do have a lot that's going to be going on in this one, but again, I want to give it to us because it's worth taking a look at and seeing how we go through these. So we are told one number is 11 less than another. If their sum is increased by 8, the result is 71. Find the 2 numbers. So we have a lot that's going on here. It sounds like we almost have 2 equations that are going on with this because we're told something here in this sentence and we're told something in our next sentence. So we may end up needing to make 2 equations with this thing. So let's take a look at our first ones. We're told one number is 11 less than another. Okay. So I'm going to have 2 numbers that are showing up in here. I've got one number and I've got another number. We can think of it in general terms. We know something about the relationship between the 2, mainly that one is 11 less than another of them. So okay, so we've got 2 numbers. We got some information about them. If their sum translates into addition. So if their sum, these 2 numbers, the sum of the 2 numbers is increased by 8, the result is 71. So I've got 2 numbers, and if I know their sum is increased by 8, my result is 71. Find the 2 numbers. Okay. So again, there's a lot that's going on here with this. There's a lot of ways we can go through and solve this as well. A lot of options, a lot of them are correct, but we have to be very, very methodical with how we're going to translate these things. So let's take a look at our first statement here and see what we can do with that. One number is 11 less than another. So we have to figure out how we're going to translate this thing. So let's just look at this, go back to our whiteboard, and we'll take a look at what we can do with this. Actually, before we do that, we'll take a look at some buzzwords in here. Is, it's our equal sign. One number is 11 less than another. So we need to figure out how to translate this thing, less than. Now, we previously just worked with some inequalities. The thought might be, well, I need to set up an inequality in here. It turns out we're not going to have to do that because we already have an equal sign that's shown up in this problem. So we don't need to worry about inequalities for this thing. But what does less than translate into an algebraic statement? Is it addition, subtraction, multiplication, or division? So looking at our English to algebra page, I'll jump us over to that. We're seeing where is that less than phrase showing up as a buzzword. So I'm looking through addition. I don't see it in there. Looking through subtraction, less than. Okay, so less than corresponds with subtraction. And let's see if we maybe can find an example of it in here. So we've got, there we go, 10 less than m. So the thing in front is subtracting from the thing in the back here. So it's kind of weird, But again, this is where the translation, and if you need this to help you, need this page to help you, this is why I'm providing it for you guys. So 10 less than m translates into m minus 10. So our problem gave us 11 less than another. We're assuming this another is a different number. So 11 less than another. So it's going to be something minus 11. So again, if you need to use this page, it's just a really, really great quick cheat sheet to use for translating these things. So with that in mind, let's jump over to our whiteboard or our blackboard, and we'll write at least this part of our sentence down. So in our third example, we were told one number is 11 less than another. I don't know either of these numbers right now, so I'm going to have variables showing up. So I'm going to arbitrarily choose m and n. Actually, we'll just do xy. Use a standard xy for this. So one number is, so I'm just going to choose x. So one number is 11 less than another. And again, with what we just saw with how to translate these things, we're going to have it be a number minus 11. So our first sentence translated over, one number is, so x equals 11 less than another. So we're going to have y minus 11. I don't know either of these two numbers. So they're both going to be variables, and that's fine. Now, I will note to you, if you are looking at this and saying, okay, great, I've got an equation, I can solve this thing, that's impossible. With one equation, it is fundamentally impossible for you to find two answers to that if we have two variables. For the number of variables that we have, we need to have that many or more equations to solve for those two variables that we've been given. So thankfully, we do have a second half of this thing showing up. I'll jump us over to that. I'm sorry for going back and forth, but I do want to let you guys see how we're translating these things as well, especially with this example. So we have our first part, we have a number, and we have something about another number. If their sum is increased by 8, the result is 71. We want to find these two numbers. Okay, so we know sum corresponds with addition. We know that from our previous example we had. So if their sum, so if I were to add these two numbers together, is increased by 8, the result is 71. So I'm going to have a number, I have another number. If I add them together, and that sum is increased by 8, let's find out what that corresponds to. Take a look at what we have over here. Increased by, it's addition. So if I have the sum of those two numbers, and then I add 8 to that, the result is 71. So again, here's our equal sign showing up in here. And I also want to demonstrate, here's an instance where is shows up there, is shows up there. So do not jump to the conclusion that is automatically means an equal sign. It does in one of these instances, it does not necessarily in the other one. So be very careful with jumping to the conclusion that is always going to translate into that. It generally will, we need to find out where it will. So writing this thing out for ourselves, because this is another problem at this point in time, or another equation. So we're told the sum is increased by 8, the result is 71. So let's write that part in. So the result is 71. So we're told if their sum, so each of these numbers, if their sum, so if I were to have the first number plus the second number, their sum, so those two things adding together, is increased by 8. You just saw it's added. So we add 8 to it. The result is 71. So we have been told, and before we go through and write this thing out or solve it, we're told one number is 11 less than another. So we have our information about our two numbers. One is 11 less than the other one. If their sum, is increased by 8, the result is 71. I think we've got this thing translated correctly now. Okay. So at this point in time, this thing written out here, oops. Now we can go through and we could solve this thing accordingly. Excuse me. Okay. So this is where it gets a little bit weird in the sense of you might be saying, okay, well, I couldn't necessarily translate all of these things into being, or translate this thing into being one particular equation. Excuse me. Grab a quick drink here. Choking on my own spit. It's not good. Okay. Better now. Excuse me. Okay. So we have two numbers that are being added together here. And we can work with translating these things over and solving it out accordingly. So now I have my two numbers that I'm going to be adding together here. I can substitute one of these in for our other number that we have. So the idea behind this is I can plug in our first equation, or this thing, in for x and our second equation. We can solve these things accordingly. Real sorry about this. I mute myself again here. Okay. So I have the sum of these two numbers. I increase it by 8, and I'm going to get my final answer. Now, the problem that we have here is that we have two separate, we have two variables written into one single equation. We can't necessarily solve it in that regard. So we're going to substitute this thing in over here, and we're going to find our answer that way. And I'm also, so I'll write out how we start this thing. And then I am going to jump us over to, I am looking at the time, and I do want to give us some time to go through some group problems as well. So I'll start how we will translate this thing over, or substitute this thing in, and then I'll let you guys solve the rest of it out from there. It's a mechanical process from this point on, and we would find our two answers. So I'm substituting this in for x. I'm getting y minus 11 plus y minus 11. We get that there. And we would go through, we can solve this thing out. We'd solve it out for y. We would find y equals a number. And then we could plug that in to our original equation, or our other equation that we have, and we would find that x equals a number. Okay. Now again, the reason I'm going through and leaving this like this is I do want to give us time to go through some other problems as a group and take any questions that you guys have as I'm looking at our time here as well. So again, it's that setup process. It's extraordinarily important as we're going through this, and and making sure that we are translating these things in accordingly as we're making that happen. So from here, I'm going to end our recording. I'll take some questions for you guys, and then we'll go through a couple of group problems, and then see where we're at with that, and then potentially go on to 3.3 from there. So I'm going to end the recording here, and we will take a look at some of these other problems accordingly.